Assalamualaikum. My name is Abdul Muiz Fahmi bin Abdul Rahman. So first I will explain about introduction of our group project. So Malaysia experienced two major monsoon seasons. The notice from February to November brings heavy rainfall. Second is rainfall process including runoff effect flood shown in hydrograph, particularly during the northeast monsoon. Okay, lastly is factor affecting water level like topography, land use and climate change along with rainfall intensity, which heavy rainfall typically leading to rising water levels and increased stream flow. Okay, for problem statement for our project is urbanization and increase runoff, loss of natural flood storage and importance of hydrograph data for flood control system design. Use data from the Sungai Dunga station to calculate key metrics like mean annual rainfall and peak flow for improving flood management.
The objective of our project is to calculate the chosen catchment area's average annual rainfall. Second is to evaluate the chosen catchment area's peak flow and river discharge at its highest water level. And third is to determine and plot the unit hydrograph for the desired catchment area.
For the methodology is the Department of Irrigation and Drainage use website in Public Info Banjir, and we can collect data of total rainfall, water levels and flood alerts across Malaysia, and we collect data from January 2023 to December 2023. Next for methodology is our group use Google Earth Pro because Google Earth Pro can view 3D terrain and 360 perspective, and Google Earth Pro can zoom in on specific location we use. So next is geographical characteristic is encompass both natural and man-made elements that define a location unique features and influence its climate, ecosystem, and human activities. Next, our group used three methods for complete this project. First is rational method to determine the peak flow rates in the drainage region while accounting for the runoff coefficient. Second method is Manning equation used to compute the discharge of water flow through a certain point in a river base on slope and cross-section area. And lastly is hydrograph method. So, hydrograph table in Department Irrigation and Drainage website, and rainfall and water level data collect from January 2023 to December 2023. Next, this is our station Kampung Pasir Raja at Sungai Dungon, and we collect our data at this station.
Next, this is our presentation data for rainfall from January to December. As you can see in the slide, I also attached the highest rainfall for 2023, which is in December, 1,208. Then this is the data presentation for rainfall event. The highest rainfall event at station Sungai Dungun, Kampung Raja, is in February, which is 345. As you can see, I also attach the graph here.
Next, I will continue this presentation with the water level data. As you can see, this is data from the January to December. And from the previous slide, rainfall event have three highest data, which is in the February, March, April. And for this water level, we take for the March, which is 1180.86 for the water level.
I will continue with the data analysis and result part. The first thing we find is peak flow. Peak flow is refers to the maximum rate of discharge during the storm runoff period. It is mostly influenced by basin and storm characteristic. So we are using the formula based on the MASMA second edition, which is peak runoff QP equal to ICA divided by 360, which is I average rainfall intensity, we get 62.1. C, which is runoff coefficient, we using 0.4, which is open space and forest cover. And drainage area in hectares, we use 665, which is from the Google Earth Pro program. So we divided the total with 360 and we got 45.885 meter cube second. The next method that we use to find the peak flow is Manning equation method. Manning equation using the slope area. There is a technique for estimating stream flow indirectly. This method calculates water discharge in a river based on slopes and cross-sectional area. Using the shape of the cross-section, which is upstream, midstream and downstream, which was a triangle formed by the cross-section of Dungu River at Kampung Pasir Raja, we can find the parameter and cross-sectional area of the cross-section. The first cross-section, which is upstream, we get area 33.7 and perimeter 70.6. For the second cross section, we get 481.6 for the area and the perimeter is 153. And the last cross section, which is downstream, we get 135.9 for the area and for the perimeter is 97. Using the formula for Manning equation, which is discharge Q, we get 60.27, 10,000, 12.46, 558.1, and the total we divided by 3 to find the average peak flow and we get 3,528.93. Next, the hydrograph. Hydrograph is a diagram of a river, stream or other water system discharge over time. It usually shows an increase or decrease in water flow versus time, which can be hourly, daily, monthly or yearly depending on data recorded. To plot the graph for the hydrograph, we use the discharge that we get from the Manning equation. Then for the upstream, this is the graph. Same goes with midstream and downstream. After we get the discharge value, we have to plot the graph and this is the graph that we get. To find the unit hydrograph ordinates, we use straight line method, which is using the straight line technique that shown here offers a straightforward approximation for separating the base flow from the rapid response flow. To find the unit hydrograph ordinates, we are using the data from 23 December of 2023 until 27 December. So to plot the graph, we have to find the direct flow, which is the formula direct flow equal to discharge minus base flow, and to find the UH ordinate equal to direct flow divided by runoff depth. So this is the unit hydrograph for the upstream. Same goes to the midstream and the downstream.
In our discussion part, our study involved an examination of the hydrological process of Dangan catchment in Pasir Raja, Terengganu. The tropical monsoon climate of this area experienced heavy rainfall, especially during the northeast monsoon season, thus making it highly prone to flooding. We aimed at recognizing the rain patterns and their effects on the water levels, as well as establishing its highest water level prediction for the peak flow and river discharge. For river analysis, precipitation information was carefully collected over a 12-month period and analyzed using this polygon method with a higher mean annual precipitation, which is 10.69 millimeter. The Thyssen polygon method allows for placement of weather stations such that localized variations are accounted for, which is necessary for accurate hydrological modeling and flood forecasting. Analysis of hydrograph. Hydrograph were utilized as a graphical representation for observing the changes in river discharge over time. These are crucial tools in comprehending how rainfall events result into runoff and subsequently affects river flow. In particular, there are significant increase in peak during heavy rain seasons such as the northeast monsoon. Computation of peak flow or calculations of peak flow. Rational method estimated peak flow rates in a small catchment with a peak flow value of 45.5 meter cubic per second. The meaning the meaning equation considered channel slope and roughness, provided an average peak flow of 3,528.93 meter cubic per second, highlighting the need for accurate watershed modeling. Geographical and topographical events. Using tools like Google Earth, accurate maps could be drawn that help to get a better understanding of hydrological behavior of the catchment. The detailed examination of the ground surface uncovered how important topography becomes for flow and storage of water, particularly on that receive lots of rain, therefore resulting into floods. Finding Findings implications. The findings from our study have a significant implication for flood management and water resource planning in Dangan catchment area. It is important to know accurately the volume of rainfall as well as runoff formulation so that it can inform building more efficient structures to prevent floods such as stormwater, sewers, or dikers. Also, knowledge on where rain is falling now can enhance better flood forecasting model that lead to disaster early warning system. In conclusion, this study has provided an extensive examination of the hydrological dynamics in Rangan catchment at Basraja, emphasizing the critical relationship between rainfall patterns and river discharge. Key findings demonstrate that it is important to use multiple techniques for more accurate hydrologic estimates necessary for flood control and water resource planning. For key findings, rainfall measurement. This method was the most effective way to capture rainfall variation at local level. One peak flow estimation, the main equation was used to obtain peak flow rate, which was higher compared to regional method with highly likely accuracy, reflecting actual hydrological conditions of the catchment area better. Flow risk management. Further, this research underscores understanding temporal and spatial changes in rainfall and runoff. Understanding these dynamics is essential in developing effective strategies and infrastructure for managing floods, and especially in regions characterized by intense rainfall or flooding. For implication for practice, this study has provided insights that can shape improved flood management systems in other areas with similar climate and topographical features as those present, presented herein. The application of advanced hydrological simulation techniques, which was done in this study, can improve the accuracy in flood risk evaluation and build resilient infrastructure. The findings also indicate that continuous data collection and monitoring are important for enhancing the reliability of hydrological models. For future research direction, for future research, there is there is a need for long-term data collection to further refine the hydrological models used in this study, including climate change projections will illuminate how changing weather patterns may influence the rainfall and flood dynamics in the future. Furthermore, remote sensing tools should be utilized alongside GIS to enhance that spatial resolution to an accuracy of hydrological data. In addition, socioeconomic impacts of floods as well as effectiveness of different mitigation measures against flooding should be explored as to give policymakers as well as planners valuable lessons. These results can be translated into practical flood management plans in order to minimize negative effects caused by floods and affected communities and promote sustainable water resource management across Malaysia and other countries beyond it.